There is something almost poetic about the way the most guarded secrets tend to unravel. Governments spend billions constructing walls of classification, deploying counterintelligence units, implementing compartmentalized security protocols, and yet sometimes all it takes is one window seat on a commercial flight to bring everything crashing down. And I find this particular story absolutely fascinating because it demonstrates something that intelligence agencies around the world have always known but rarely admit. You cannot hide something that flies in the sky forever. The year was 1981. The Cold War was reaching one of its tensest periods. Ronald Reagan had just entered the White House with aggressive rhetoric against what he famously called the evil empire. The Soviet Union, under the aging leadership of Leonid Brezhnev, was pouring resources into military projects designed to counter American technological superiority. And somewhere in the vast industrial complex of the USSR, engineers were putting the finishing touches on what would become the largest and heaviest combat aircraft ever built, a machine so ambitious that Western intelligence agencies refused to believe initial reports about its existence. The Tupolev Tu-160, which NATO would eventually designate the Blackjack, was not just another bomber. It was a statement.
How?
It was the Soviet Union's answer to the American B-1 Lancer. Except the Soviets, being the Soviets, decided that their version needed to be bigger, faster, and capable of carrying more nuclear weapons than anything else in the sky. This was a machine designed to penetrate the most sophisticated air defense networks on the planet, deliver its payload, and return home. And for years, its very existence was one of the most closely guarded secrets in Soviet military history. But here's where the story takes an almost absurd turn, because despite all the security measures, despite the restricted airspace, despite the KGB's legendary paranoia about Western spies, the Tu-160 was exposed to the world not by a CIA operative, not by a defector, not by satellite imagery, but by a random passenger on a commercial Aeroflot flight who happened to look out the window at exactly the wrong moment for Soviet secrecy. Now, before we dive deeper into this incredible story of accidental exposure, if you are enjoying this kind of content about Cold War secrets and military technology, I would really appreciate it if you hit that subscribe button and give this video a like. It helps the channel grow and allows me to keep bringing you these fascinating stories that mainstream history often overlooks. Trust me, this one only gets more interesting from here. So, let us set the stage properly to understand why the Tu-160's exposure was such a catastrophic intelligence failure. You need to understand what the Soviets were trying to achieve with this aircraft and why they were so desperate. To keep it hidden, strategic bomber had been central to nuclear deterrence since the dawn of the atomic age. When the United States dropped nuclear weapons on Hiroshima and Nagasaki, they did so from B-29 Superfortress bombers. In the immediate post-war years, the bomber was the only means of delivering nuclear weapons, and both superpowers invested heavily in developing intercontinental bombing capability. The Soviets, starting from a significant technological disadvantage,
worked frantically to develop aircraft that could threaten the American homeland. By the late 1970s, the strategic bomber competition between the superpowers had reached a critical juncture. The United States had been developing the B-1 program, a variable geometry supersonic bomber designed to replace the aging B-52. The B-1 represented a new philosophy in strategic bombing. Instead of relying purely on high altitude and speed, it would use a combination of low-level penetration, terrain-following radar, and reduced radar signature to slip through Soviet air defenses. The Soviet leadership watched these developments with growing concern. Their existing bomber fleet, while impressive in size, was becoming increasingly vulnerable. The Tupolev Tu-160 Bear, with its distinctive counter-rotating propellers, was a magnificent piece of engineering. But it was loud, slow by modern standards, and its radar signature made it relatively easy to track. The Myasishkov M4 Bison was similarly aging. The Soviets needed something revolutionary. What fascinates me about this period is how both superpowers were caught in a technological arms race where each advancement by one side required a response from the other. The Americans developed the B-1 to counter Soviet air defenses. The Soviets needed a new bomber to counter American air defenses. The Americans would then need to upgrade their defenses and so on in an endless cycle of action and reaction. This dynamic drove enormous investment in technological innovation, but it also created tremendous waste and risk. Enter the Tu-160 program. What fascinates me about this aircraft is that it represents perhaps the most ambitious aviation project the Soviet Union ever attempted. The requirements were staggering. The aircraft needed to be capable of sustained supersonic flight, carry a massive payload of cruise missiles and nuclear weapons, have intercontinental range, and incorporate the latest in Soviet avionics and material science. This was not an evolution of existing designs. This was a leap into entirely new territory. The Tupolev Design Bureau, led by the legendary Alexei Tupolev, son of the Bureau's founder, Andrei Tupolev, took on the challenge. The elder Tupolev had been one of the giants of Soviet aviation, designing iconic aircraft like the Tu-95 and surviving Stalin's purges.
Being imprisoned in a sharashka, a prison laboratory where captive scientists were forced to work on military projects. His son inherited both his technical genius and his position at the top of the Soviet aviation establishment, and what they created was genuinely remarkable. The Tu-160 would emerge as the largest variable sweep-wing aircraft ever built, the heaviest combat aircraft in history, and the fastest bomber ever to enter operational service. Its sleek, elegant lines belie its true purpose as a nuclear weapons delivery platform capable of striking targets across the globe. But here is where I think many people misunderstand the Tu-160's design philosophy. When Western analysts first got detailed information about the aircraft, many criticized it as simply a scaled-up copy of the American B-1. This criticism has always struck me as both unfair and inaccurate, as both aircraft use variable geometry wings, as both were designed for similar strategic roles. But the Tu-160 represents fundamentally different design choices that reflect Soviet strategic thinking. The B-1B, which eventually entered American service, was optimized for low-level penetration. Its designers accepted that supersonic dash capability at low altitude would be limited, focusing instead on terrain-following ability and reduced radar cross-section. The Tu-160, by contrast, was designed around high-altitude supersonic cruise. The Soviets bet that their aircraft could simply outrun interceptors and that speed and altitude would be more valuable than stealth. This difference in philosophy would have profound implications. The Tu-160 can sustain speeds of over Mach 2 at altitude, making it significantly faster than the B-1B, however. This comes at the cost of a larger radar signature and less sophisticated terrain-following systems. Either approach is inherently superior. They represent different solutions to the same strategic problem. I find it fascinating how the same basic requirement penetrating enemy air defenses to deliver nuclear weapons led to such different design outcomes. The Soviet approach reflected their broader military philosophy, where American doctrine often emphasized technological sophistication and quality. Soviet doctrine tended to favor quantity, simplicity, and brute force. The Tu-160 embodied this philosophy in its focus on raw performance metrics: speed, range, payload. The Soviets built the biggest, fastest, most powerful bomber they could, trusting that these qualities would prove decisive. Now, developing such an ambitious aircraft required an enormous industrial effort. The Soviet aviation industry had to develop new titanium alloys, new manufacturing techniques, and entirely new propulsion systems. The NK-32 turbofan engines that powered the Tu-160 remain to this day the most powerful engines ever fitted to a combat aircraft. Each engine produces over 55,000 pounds of thrust with afterburner, and the Tu-160 carries 4 of them. The engineering challenges were immense. The titanium work alone was a remarkable achievement. Titanium is an incredibly difficult material to work with. It reacts with oxygen at high temperatures, making welding challenging. Spies. It requires specialized tooling and manufacturing processes. It is expensive and difficult to source. Yet the Soviets had developed considerable expertise in titanium metallurgy.
Through earlier programs, particularly the MiG-25 interceptor and the Alpha-class submarine, this expertise proved essential for the Tu-160, the MiG-25, which I find to be one of the most fascinating aircraft of the Cold War, had pushed Soviet titanium capabilities to new levels. Designed to intercept the planned American B-70 Valkyrie bomber, which was ultimately canceled, the MiG-25 was optimized for speed above all else. It could reach speeds of over Mach 3, making it one of the fastest
aircraft ever built. The thermal stresses at these speeds required extensive use of steel and titanium in the airframe. The lessons learned from the MiG-25 program directly informed the Tu-160's development. All of this work had to be conducted in absolute secrecy. The Soviets were deeply concerned that any intelligence leak would allow the Americans to develop countermeasures before the Tu-160 even entered service. The aircraft was developed under multiple code names, with different facilities working on components without full knowledge of the overall project. Test flights were conducted from remote airfields with strict security protocols. Airspace was closed, radar coverage was manipulated, and workers were subjected to intense background checks and monitoring. The KGB's involvement in protecting the Tu-160 program was extensive. Security personnel were embedded at every level of the project. Communications were monitored. Foreign contacts were investigated. Even senior engineers had to submit to regular security reviews. The level of paranoia was extraordinary, even by Soviet standards. And yet, despite all these precautions, the secret got out in the most mundane way imaginable. The exact circumstances of the leak have been discussed and debated for decades, but the basic story is well established. In November 1981, a commercial Aeroflot flight was traveling over the Ramenskoye airfield, a major Soviet aviation test facility located southeast of Moscow. This airfield, also known as Zhukovsky, was the Soviet equivalent of America's Edwards Air Force Base, the place where experimental and prototype aircraft were tested before entering production. Among the passengers was someone, possibly a foreign national, possibly simply a Soviet citizen with connections to Western intelligence, who looked out the window and saw something extraordinary. There on the IR tarmac below sat an aircraft unlike anything the world had seen. Its distinctive shape, with swept-back wings and a sleek fuselage, was clearly visible. The observer, whoever they were, managed to provide a description of what they had seen to Western intelligence services. Some accounts suggest photographs were taken, though this has never been definitively confirmed. What I find remarkable about this incident is how it illustrates the fundamental vulnerability of any large-scale military program. The Soviets could control their airspace. They could restrict access to manufacturing facilities. They could compartmentalize information, but they could not prevent their own commercial airlines from flying over their test bases. The very infrastructure of Soviet society, which required domestic air travel to function, created a window of vulnerability that no amount of security could completely seal. This was not the first time such a thing had happened. In Fiji
1960, Gary Powers' U-2 spy plane was shot down over the Soviet Union, causing a major international incident. But at least the U-2 was a deliberate intelligence operation. The Tu-160 was exposed by accident by the routine operation of civilian infrastructure. The Soviets, for all their security measures, had failed to consider this possibility. The intelligence community in the West was electrified by this information. For years, there had been hints and rumors about a new Soviet bomber program. Satellite imagery had shown construction of unusual facilities at certain airfields. Communications intercepts had picked up references to advanced aviation projects. But this was the first concrete evidence that the program had reached the prototype stage. I want to emphasize how significant this moment was for Western intelligence. The Cold War was fundamentally an information war. Both sides devoted enormous resources to gathering intelligence about the other's capabilities. Every new weapon system discovered was a piece of the puzzle, helping analysts understand the overall threat picture. The Tu-160 represented a major gap in Western knowledge, and its discovery prompted intense efforts to learn more. What followed was an intense effort to gather more information. American intelligence assets were redirected to focus on the Tu-160 program. Satellite tasking was adjusted to increase coverage of Soviet aviation facilities. Human intelligence sources were queried for any additional details they might have access to. And gradually, a picture began to emerge of what the Soviets had created. The methods used to gather this intelligence were varied and sophisticated. Signals intelligence, or SIGINT, monitored Soviet communications for references to the bomber program. Imagery intelligence, or IMINT, analyzed satellite photographs of production facilities and test sites. Human intelligence, or HUMINT, relied on agents and defectors who could provide first-hand information. All of these sources were combined and analyzed by teams of specialists who gradually assembled a comprehensive picture of the Tu-160. The implications were significant. American defense planners had to consider how this new Soviet bomber would affect the strategic balance. What would happen if the Soviets could field a fleet of aircraft capable of supersonic penetration of North American air defenses? How would this affect arms control negotiations? What countermeasures would be needed? I think it is important to pause here and consider the broader context of this intelligence coup. The early 1980s were a period of intense superpower competition. The Soviet invasion of Afghanistan in 1979 had shattered the détente of the previous decade. Reagan's military buildup was gathering momentum, with massive increases in defense spending and aggressive rhetoric about Soviet to date military capabilities. In this environment, any intelligence about Soviet military programs was eagerly consumed by Western decision-makers. The exposure of the Tu-160 fed into a narrative that the Reagan administration was promoting, that the Soviet Union was engaged in a massive military buildup that threatened Western security. The bomber gap of the 1950s, which turned out to be largely imaginary, now seemed to have a modern equivalent. Here was concrete
evidence of Soviet military ambition. The bomber gap deserves a moment of reflection because it illustrates how intelligence can be misinterpreted for political purposes. In the late 1950s, American intelligence overestimated the number of Soviet long-range bombers, leading to fears that the Soviet Union was ahead in the strategic competition. This bomber gap was used to justify increased American military spending. When more accurate intelligence became
available, it turned out that the Soviets had far fewer bombers than estimated. But by then, the political damage had been done, and the arms race had accelerated. But I want to offer a more nuanced perspective on the Tu-160's significance. While the Tu-160 was indeed an impressive technical achievement, strategic significance was perhaps overstated by those who had political reasons to emphasize Soviet military power. The program was plagued by delays and cost overruns at the Soviet economy. Already straining under the burden of military spending, could not afford to produce the Tu-160 in the numbers originally planned, and the aircraft's high-altitude supersonic penetration strategy was becoming increasingly questionable as American air defense systems improved. The accidental exposure of the Tu-160 did not, in the end, significantly accelerate Western countermeasures. The Americans were already developing the systems that would eventually
render high-altitude supersonic penetration obsolete. The F-15 Eagle, already in service, could intercept aircraft flying at the Tu-160's preferred altitudes. The development of look-down, shoot-down radar systems was making low-level penetration equally challenging. The strategic environment was shifting regardless of what intelligence the West gathered about Soviet bomber programs. What the exposure did accomplish was to confirm suspicions and provide a concrete target for intelligence gathering. Over the following years, Western agencies would accumulate extensive information about the Tu-160, its capabilities and its limitations. By the time the aircraft was officially revealed in 1987, when Soviet leader Mikhail Gorbachev showed it to a visiting American delegation, there were few surprises left. Now I want to shift our focus to examine the Tu-160 itself in more detail, because I think the technical story is just as fascinating as the intelligence story, and understanding the aircraft helps us appreciate both what the Soviets achieved and where they fell short. The Tu-160's most distinctive feature is its variable geometry wing. The wings can sweep from a minimum of 20 degrees for takeoff and landing to a maximum of 65 degrees for high-speed flight. This allows the aircraft to optimize its aerodynamic configuration for different phases of flight. With wings extended, the Tu-160 has good low-speed handling characteristics and can operate from relatively short runways. With wings swept, it can achieve supersonic speeds with reduced drag. Variable geometry wings were fashionable in aircraft design during the 1960s and 1970s, but they come with significant penalties. The pivot mechanisms add weight and complexity. The structural requirements are demanding. Maintenance is more intensive than for fixed-wing aircraft. By the time the Tu-160 entered service, most air forces had moved away from variable geometry designs. The Americans would not build another swing-wing aircraft after the B-1. The Soviets, characteristically, committed to the technology and pushed it to its limits. The physics of variable geometry wings is fascinating. At low speeds, a straight wing provides better lift and handling characteristics. At high speeds, a swept wing reduces drag and allows for higher velocities. By allowing the wing to change configuration, variable geometry aircraft can optimize performance across a wide range of speeds. However, the mechanisms required to allow this movement are complex and heavy, eating into the aircraft's useful payload. The airframe itself is a marvel of Soviet metallurgy. The Tu-160 makes extensive use of titanium alloys, which offer superior strength-to-weight ratios compared to aluminum, but are notoriously difficult to work with. Soviet industry had
developed considerable expertise in titanium processing through programs like the submarine, fleet, and the MiG-25 interceptor. This expertise was essential for the Tu-160, which could not have achieved its performance goals with conventional materials.